Hey everyone, welcome to part 3 of our 3.2 video lessons on least squared regression lines. So in the learning targets here, we can see that several targets are highlighted. These are the ones that are going to be covered in this video. We want to be able to determine the equation of a least squares regression line using a computer output. We want to be able to interpret the standard deviation of the residuals and R squared and use these values to assess how well a least squares regression line models the relationship between two variables. And lastly, we want to be able to find the slope and y-intercept of the least squares regression line from the means and standard deviations of x and y, as well as their correlation. So as a quick review of what we've already discussed so far in 3.2, a regression line is simply a line that allows us to make predictions for y given an x or for x given a y. So the form of our regression line is y hat equals a plus bx, where y hat is the predicted outcome for any given x value. A is the y-intercept, which is the predicted outcome when x is equal to 0. B is the slope, which is how much y hat changes for every 1 unit of x. And x is just simply any given explanatory variable value. So we can use our calculator to generate that least squares regression line. Again, we put our data into list 1 and list 2. We hit the stat button. We go over to calc, and option number 8 was lin reg a plus bx. And so it will tell us what our a value is, what our b value is, and then we substitute those in. Once we have our least squares regression line, we can use that information along with a given y or a given x to find the other missing variable, and that's what we had here in these examples. We talked about an extrapolated value, which happens when we have an x value, or we input an x value into our least squares regression line equation, but the x value that we're using is one that's well beyond those that were used in order to generate the least squares regression line that we're using. Thus, it often produces very inaccurate responses. A residual is another word for an error. So whenever we have an inaccurate response, there's a residual that exists. The residual is calculated by doing the actual y minus the predicted y. When we look at this visually, the regression line is our predicted y values. That's what that is. So that blue line is the predicted y value for each given x. The red dots are the actual y values. The residual is just that distance between the two. It's the difference between them. So we talked about how we calculate a residual and how to interpret those. And then there's a lot more review. So then we had a residual plot. So a residual plot is taking the least squares regression line, and as we talked about before, just kind of rotating it so that the regression line is now horizontal, and then the residuals will be above or below. And what we said was if there is no pattern within the residual plot, what that meant was we have linearity, or a linear relationship is appropriate. Whereas when we do have a pattern, such as a curve, or we talked about here, as x increases, so are the residuals, something like that, a linear model is not best. We don't necessarily know what model is best, we just know that it's not linear. So we've got the steps here on how to make a residual plot, and we practice one of those. Where we ended with in the previous video lesson was talking about the two different ways to determine how well our line fit our data. So the residual plot says, yes, a line is good, or no, a line is not good, but it doesn't tell us how good it is. So the standard deviation of the residuals tells us the typical residual, or in other words, about how far off is any given guess from the actual value. Then we also had the coefficient of determination, which we just call R squared. R squared measures the typical percent of the variation in the response variable that can be explained by its linear relationship with the explanatory variable. It's just simply the correlation value squared. Okay, and so we just did some examples with those. Now what we're going to do is we're going to take what's called a computer regression output, and we are going to learn how can I take this. So what pretty much all of us use is a Texas Instrument calculator. right? That's one of many different software outputs that exist. Okay, there's a lot of different statistical softwares and tools that are used, and those displays are going to look a little bit different. So it's important that we're familiar with some of the most popular ones. So, excuse me, first one is called a Minitab output, and that's going to look like this format here in this white box. So it's going to say predictor, and then underneath that it's going to say constant, and it's going to say one of your variables. So in this case, we had a comparison comparing height to weight. And we have a lot of information. So what I'm going to do is I'm going to first simplify this. SE coef, T, and P. We will never use these. Okay. It's not within the scope of our course, so you will never need to use those. Okay. Same thing with the R squared adjusted. Okay. So when we narrow down what other information we have, we've got this constant, we've got this height, we've got this S equals, and we've got this R squared equals. So let's just start with some of the easier ones. This S is the standard deviation of the residuals. So in this case here, if we're comparing height to weight, weight is going to be that output. So what it's saying is that typically our predictions are going to be off by 8 pounds. That's the typical error. So if we have all of these, that's our typical error. R squared, very simply, R squared, in this case is 89.7%. So 0.897 is R squared. Now, one thing that AP loves to ask about is, given a Minitab output, what is the correlation? And more often than not, students are going to say this. Remember, correlation is just R. So what we have to do next is we have to say, okay, well, if R squared is 0.897, I would take the square root of both sides. The one thing that you have to remember is, and let me just figure out what that is really quickly for us. 0.897 is 0.947. When we introduce a square root into the problem, this is a very old algebra rule. Remember that it could be both the positive and the negative version of it. And remember that correlation could be positive or it could be negative, anywhere from -1 to 1. So what we need to know is, how do we tell whether correlation is positive or negative? And we'll come back to answer that in just a second after I go over what these two values mean. Over here we have the predictors for the constant and for the height, and we have what are called their coefficients. So really quick algebra review. Remember that a coefficient is the number in front of a variable. So for example, if I have 4x, 4 is the coefficient. Okay, x is the variable. Now, if I go back to our y equals a plus bx, one of these terms is called the constant. The constant is the term without a variable. Technically it does. It would be like ax to the 0. Well, x to the 0 is just 1. A times 1 is just simply a. So what this is saying is that the coefficient of the constant term is negative 266.53. This right here is my a. So my least squares regression line is going to be y equals negative 266.53. And then I need to know what's my b value. Well, my b value is just very simply going to be, what is the coefficient of height? Okay, my height is my explanatory variable. It's my x. So the coefficient of my x term is right there. So plus 6.1376x. So this is how we can get our least squares regression line from a Minitab output. Now that we know this information, I want to go back to how do I know if correlation is the positive 0.947 or the negative 9.47? Well, remember correlation tells us strength and direction. It tells us are the dots in the scatter plot increasing or decreasing as x goes up. And so in this particular case, if I look at the slope, of my line, I have a positive slope. My line of best fit is increasing as x goes up. That means my correlation has to be positive. Therefore, this is going to be positive 0.947. And I'm going to put this as a little note here. If slope is positive, R is positive. Whereas if slope is negative, then R is negative. Okay. And so what this does now is it gives us a rule to where if I have a Minitab output, I can determine both the equation of the least squares regression line from using the coefficients, and I can determine what is the standard deviation of the residuals. I can determine what is R squared, and I can determine what is R. Okay. So those are from what we call a Minitab output. Another very common statistical software that is used is called a JMP output. The JMP output is going to give us the same information as a Minitab output, plus a little bit more, but we only need to focus on the necessities again. So things that we will cross out, which will be the reds. R square adjusted. Okay, we do not need to know that. Mean of response. We do not need to know that. Observations. We do not need to know that. That's just how many data values there are in the set. Standard error. We don't need that. T ratio. We don't need that. And that's, again, when I say we don't need it, it's not to say that it's not important. It's just information that goes beyond the scope of this course. Okay? So what we have left over are some of the important pieces that we need to know. So I'm going to try to keep things color coordinated here. The root mean square error right here. This is your standard deviation of residuals. Okay, different name, but same concept. Okay, hopefully this next one pretty straightforward. R square is just the R squared value. And then down here, we use a little bit of different terminology. We've got term instead of predictor. And then we've got intercept. Well, hopefully that's pretty straightforward. This is our A value. It's our y-intercept. So in this case, y hat is equal to 97.294, so on and so forth. And then age right here is going to be my slope. And I can see in this case, it is a negative 0.20, so minus 0.20x. Right here is my equation of my least squares regression line from a JMP output. And then the one thing that we haven't addressed yet is based on the JMP output, what is R? Well, again, R squared is equal to 0.850676. So if I want to know what is, excuse me, R, then I just need to take the square root of 0.850676, and I get 0.922. But remember, it could be plus or minus because we take the square root. We introduce that square root into the problem. And if I use this rule here in purple, if slope is positive, R is positive. If slope is negative, R is negative. Well, my slope was negative 0.20. Therefore, R is negative 0.922. There is a negative correlation. As X increases, Y decreases. Okay, so now that we've done that, let's take a quick moment to practice this. For example 9, use the software output to answer the following questions regarding monthly income to monthly mortgage and utility payments. So if we look here, we can see that we have an example of a Minitab output. Remember that right from the get-go, I don't need this, I don't need this, I don't need this, and I don't need this. So, part A, find the correlation. We just need to know that means what is R. Well, first of all, it doesn't tell us what R is. It tells us that R squared is 91%. In other words, 0.91. So if I want to know what R is, I take the square root of each side. R is going to be plus or minus square root of 0.91. So that's going to be 0.95. And in order to determine which one it is it positive or negative, I look up here for the slope. I see that is a positive slope. Therefore, my correlation is 0.95. What is the equation of the least squares regression line that describes the relationship? So again, that's going to come from this information here. We start with our y hat equals a plus bx. Well, we want to define any variables that are used. So income is our x, mortgage is our y. So the predicted mortgage is going to be equal to A, which is our constant right here, 438.525. And then we already said the slope was positive, so it's going to be plus whatever the slope is. And that's the coefficient of income, 0.51145. There is our least squares regression line. The predicted mortgage is going to equal 438.525 plus essentially half of whatever the monthly income is. Lastly, by about how much do the actual mortgages vary from the values predicted by the least squares regression line? This is asking us for S. What is the standard deviation of the residuals? How much do the actual vary from the predicted? And I can see that value right here. Okay. Values vary by about $12.22. Now, for the last thing we are going to do today, we are going to figure out how can I find the least squares regression line with different information. So if you have all of the data pieces available to you, or if you have a Minitab output, that's all very beneficial for you. But if you don't have that, if you have a different set of information, we need to know how can I find my least squares regression line from there. So 3-step process. First one, If not done already, calculate x bar, y bar, standard deviation of x, standard deviation of y, and r. Those are all things that would just be done on the calculator using one variable statistics or calculating your least squares regression line. Now, because the information we would need for this would be put into our calculator anyways, and our calculator has the capacity to generate the least squares regression line, we should just do that. So instead, what we're going to do is look at an example where we don't have all the individual data values and go from there. But step 2, find b, which is the slope, by computing this equation. B is equal to r times the standard deviation of y over the standard deviation of x. And lastly, use the slope that we've just found in step 2 to find a, which is our y-intercept, by computing this equation. A is equal to y bar minus b times x bar, the average y and the average of the x's. So we're going to hold off on example 10 because example 10 just says use the dinner party information, but we already have the means, or we already have the knowledge to where if I know all of my individual data values, then I can just hit stat calc, go to option 8 for linear regression and get my least squares regression line. So let's look at an example where that's not an option. If we go to example 11 here, it says 15 high school students are chosen at random and their foot length and height are measured, both in centimeters. The mean and the standard deviation of foot length are x bar is equal to 24.76 and standard deviation of x 2.71. The mean and standard deviation of heights are y bar is equal to 171.43 with a standard deviation of y as being 10.69. The correlation between foot length and height is 0.697. Find the equation of the least squares regression line, defining any variables used. Okay, so step 1, if not done already, calculate these values. Well, we already have them. X bar, SX, Y bar, SY, correlation. So we don't have to do that. So step 2, find the slope of your least squares regression line by computing this. B is equal to the correlation times the quotient of the standard deviations. Now, really quickly, this information is provided on your formula sheet. So let me just show you that really quickly. It is right here. So on the very front page, up at the top, B equals R times SY over SX. And that's what we have right here. So this is not something you have to memorize in terms of formulas. You do have to know when to use it, how to use it. So first step, find the slope. B is equal to R times the standard deviation of Y over the standard deviation of X. Therefore, that's 0.697 times standard deviation of Y, 10.69, over standard deviation of X, 2.71. Very quick algebraic background as to how we get slope from this. Remember, correlation tells us how strong the relationship is. If my correlation is 1, that means it's a perfectly straight line. And notice we have y over x. When you think about your slope formula, that's the change in y over the change in x. Well, standard deviations are basically talking about variation or change. So this is the change in our y values, change in our x values, and if it's a perfect fit, we would multiply that by 1. So what this does, it takes into account that it's not a perfect fit. So that's just a little bit of background there. But long story short, I can go ahead and calculate this. 0.697 times 10.69 over 2.71. And I can get my slope is 2.75. Now that I have my slope, I can cross that one off the list. Now, use the slope found in step 2 to find A, which is our y-intercept, by computing A equal to x bar minus B times x bar. Once again, a variation of that is on your formula sheet. Okay, right above the slope, y bar equals A plus B times x bar. All we did here was subtract the term of bx bar from both sides to isolate A. That gives us our y-intercept. So on the left side, we would have y bar minus B times x bar equals A. So A is equal to y bar minus B times x bar. Well, A is what we're trying to find, but y bar is right here, 171.43, minus B, we calculated previously, times x bar, right here, 24.76. So if I pull up the calculator again really quickly, 171.43 minus 2.75 times 24.76, I get 103.34. Now I have my slope. I have my y-intercept. So now I can write the equation of my least squares regression line. Y hat. And again, y is here and here. It's paired with the heights. So the predicted height is equal to A, 103.34, plus B, 2.75, x. And x was their foot length. And so there's our final answer. Okay. So if you do have any questions from this, as always, please feel free to reach out. But just as a quick review, Minitab outputs, how can I write the equation of the least squares regression line from a Minitab? How can I do that from a JMP? Okay, we use that information provided. And then writing the least squares regression line from statistical summaries. Step 1, if not, you don't already have them, determine what are x bar, y bar, standard deviation of x and y, and your correlation. Then once you have those, use them appropriately to find your slope and your y-intercept, and then plug those back into a final product. Okay? Again, if you have questions, please feel free to reach out. Otherwise, thank you so much for watching, and we will conclude 3.2 with part 4 of the video lesson tomorrow. Take care, everyone. Have a good day.